Welcome. I'm delighted to see you all. I hope you're having a great day today and not getting too tired. I think that it's a lot of information coming in one day, but you've got 2 more to get through. So keep packing it in, and then by the end you'll take it back and either forget it all or get busy thinking about things you don't have time to do. I know how it is. But today is a semantics deep dive, and we're going to spend a little bit of time going a little bit further into data integration and semantics. This is a little bit of a departure from previous deep dives in semantics, which went into more technical aspects of it, because we really want to emphasize this data integration theme. And semantics was really born out of a spirit of data integration. So there's a lot of tricks that you can bring to your data integration scenarios with semantics. We'll do a little bit of basic information about how semantics work. And then Mike will take it and look at standard vocabularies and ontologies, because there's a lot of reusable data out there for semantics that you can build models from publicly available things. Then we'll go back and talk a little bit more about MarkLogic specifically and what MarkLogic brings to the table in semantics, because since we're a multi-model database, you can choose how much semantics to do. You don't have to go in whole hog. And then lastly, Mike will take it back and then talk a little bit more specifically about inference and how inference works and what you can do with MarkLogic and inference. As you just heard, we have a lot of material today, but I'll just try to go as quickly as I can through here without speaking so fast that you can't understand me, and hopefully have some time at the end for questions too. As we're going through, this isn't a recipe book for data integration, and it's more about you getting some of the tools to do things that you might normally do with data integration scenarios. So as we're going through this talk, just think about various topics when you are in data integration scenarios. You might be thinking of multiple sources of data, data aggregation, bringing it together in one place. You have to think about what it means to actually move data from one system to another and what has to happen to it in that process. One thing you'll have to do a lot is transformation of lexical values so that you can actually get your values into something that can be indexed by MarkLogic. Incorporating controlled vocabularies, translation between semantic models, and then finally inferring relationships. So these are just things to keep in the back of your mind as we continue along. So first of all, I come from a linguistics background. And I was really struck by semantics technology when I started learning about 10 years ago, because it really started with a focus on human language, and there's a very close correlation between things you know intuitively about language and about how semantic technology is put together. So when I say little s semantics, I'm talking about a linguistic discipline about meaning. And the way the terms we think about in linguistics and semantics might be sentences. Well, semantic technology with the capital S is also formed out of sentences. They call them triples. And a triple in semantics with a subject, predicate, and object is really made to mirror a sentence that we might speak in normal human languages. If you take a whole bunch of sentences together and package them up together, you get a document or a paragraph or some larger unit of sentences. In the semantic technology, those are graphs. So you take enough triples together, string them together, you get a graph data model. The syntax of those graphs, the actual technology which specifies how to make triples, that's RDF. And you'll always hear RDF. I love the fact that it's Resource Description Framework, because that means nothing. But you put it together and then it becomes a triple, R, D, and F. And if you can remember Resource Description Framework at the end of the talk, I'll have you raise your hand. So that's the syntax. On top of RDF, everything in semantics is in RDF. And SCOS is one particular standard vocabulary that is expressed in RDF, but it expresses concepts. So we can actually encode meaning and concepts in the triples, and it's all just triples. They all go together in one place. Finally, we ask questions of each other all the time, or questions of corpora. We have a query language for RDF. It's called Sparkle. So you can map between these human language concepts and semantics pretty easily. So on the right-hand side here is a typical simple XML representation of some book metadata about Anna Karenina. And I can go through and read these, and this gets me a bridge to how it might be expressed in semantics. So the book has some kind of ID. In this case, I'm calling it Anna Karenina. Its title's Anna Karenina. Its author's Tolstoy. Its price is $33.21. Notice that's not in the XML, but it's some additional information I'm putting in here. And in each case, each of these sentences on the left is in 3 parts. The book is always on the book, or In this case, it's always the book, I suppose. The book is the subject of each of these sentences. The middle is either its title, author, price, etc. And then there's a value on the other end. That's really all triples are. And once you get that concept down, you can turn it into syntactic RDF triples. The colon Ana Karenina is the ID for the book. Everything in RDF is going to have some kind of uniqueness associated with it. And that's probably the biggest jump from XML or JSON-based technologies, is that you're going to have to mint all these IDs if you make triples. You can see that the creator, DC creator of Ana Karenina, is this other guy, Leo Tolstoy, and he is the ID of that triple afterward, and he has a name. So usually you're going to string things together with identifiers, not necessarily with just strings that represent things, but full-blown unique identifiers. The thing about MarkLogic, which is so nice, is that I'm not just talking about triples and documents. I don't have to make a choice between the two. I can put everything in MarkLogic and they're going to work together. And so in a MarkLogic scenario, just right from the bat, we're talking about data integration in the sense that I can take different kinds of data. They can all live together. I can make them work together in the same ecosystem. Another very important concept for RDF is this universal identity. An IRI or URI in RDF is always going to be some big, long string, and then we have shortening mechanisms. So DC title is a shorthand for a big, long IRI, which includes perl.org and title. And the reason why I've listed all these prefixes up here is you're going to see them over and over and over again. RDF makes extensive use of standard vocabularies, and you're going to see these ones and many other ones in your models because somebody has already gone through the effort of making pretty decent models. You can reuse them and mix and match them without worrying about the fact that someone else made it and you're bringing them in. You will see the letter A a lot. A is shorthand for RDF type. And so anytime I want to say that object or an entity is in a certain class, I'm going to say RDF type is that property. And then for your questions, I can take triple patterns and prefixes and just turn them into a query. This is an example of a Sparkle query. I've got prefixes at the top, a select statement, which is saying what information I want to grab out of the RDF in this case, and then I've got some triple patterns afterwards. The first triple pattern is a complex one, which is going to crawl along that graph from some variable, s in this case. It's going to find the creator, and then find the FOF name of that creator and the author name in that case. So if I go back to my triples, I can see that Ana Karenina's creator is this IRI Leo Tolstoy, and his name is Leo Tolstoy. So if I run this query, that's the pattern that's going to match and pull up author name. So this is going to return the title, Ana Karenina, the author's name, Leo Tolstoy, and a subject. In this case, it'll be a Library of Congress subject because I took all of the published Library of Congress subject headings, threw them into MarkLogic, and I'm able to query them together with my triples right away. There's also modeling technology based in RDF. It's all still just triples. You can see Ana Karenina is a book. It might also be a product if I'm a bookseller. And I can make all kinds of assertions about identity like this, where I'm giving objects types. And you'll see further down here that a book is a class. So if I specify that something is a class, I'm not talking about an individual anymore, but rather a class of individuals. And there's a whole kind of modeling technology based all in RDF. But it's all just triples. Everything that I do, whether it's describing a model or describing an instance or describing a hierarchy, taxonomy, reference data, it's all going to be triples. And all of the data that you have expressed in triples all stays together in the same kind of data space, if you will. Even documentation for your schemas can be triples and can live in the same place, and you can query it all in one step. A good small model, you can take a good small model and reuse it over and over again. One thing that you'll never have to model again if you're using triples, for example, are people in organizations. FOF is a very small vocabulary that is used very, very extensively, and you can use that for networks of organizations and people just out of the box and as part of your own work. So before I turn it over to Mike here, just think about features of triples. We've got a way to universally encode any kind of data. We have universal interchange because a triple looks exactly the same, whether it's sitting in a database or on a file system or on a piece of paper. All you do is parse and serialize these things. You don't have to make any other decisions about how your data moves around. The triples can contain both instance data and class data, and you can reuse just about anything that you create with RDF. But one thing that you will find is that it takes a little bit of effort to create triples. They don't just kind of surface out of thin air. It takes a certain amount of investment and thought to create them. And that's why MarkLogic has something to bring to the table, because you don't have to go all in. You can choose just parts of the data you already have to turn into triples, and that can be a sliding scale and a process rather than something you have to solve up front. So we'll take a left turn now into ontologies, and Mike is going to talk about what standard vocabularies are and ontologies and how you use them in MarkLogic and semantics in general.
Presented people with common objects, common operations from different domains, I think we're good, and had them describe them. So presented them with recipe ingredients, classified ad items, text editing operations. He wanted to find out if people describe things the same way and consistently. And turns out they don't. And actually, 20% of the time would two given people give the same word for a description of a common object or a common operation. And that's really the challenge we face in data integration. People naturally describe things in different ways, and that makes data integration after the fact a challenge. How do we address this challenge? Well, ontologies are a way we can address this. Ontology is just a fancy term for a standard way of describing things. So an ontology lets you be consistent with other people in your field in describing the same things, the same operations, the same concepts in your semantic application. So if everyone uses the same ontologies, then everyone's data is going to be more consistent. You're going to have easier data integration, right? That's really the optimal situation that we want. So here's an example of an ontology in use, the friend of a friend ontology, or just FOF. And we're describing Jimmy Wales, the founder of Wikipedia. And we're using a bunch of properties, standard properties described by FOF. And in the FOF spec, it describes the meaning of these properties. We can say, what Jimmy's email address is, his homepage on the web, his nickname, et cetera. And so we're using standard predicates to describe Jimmy. And anyone else with, say, a MarkLogic semantic application can import these FOF triples, make use of them, and have a more standard, consistent data model, and which will make data integration much easier. All right. How do you go about creating an ontology? So let's pretend we want to create one from scratch. In the real world, you'll probably try to find ones that are already out there. But let's say we want to create an ontology about cars. Say things like cars, type of vehicle, convertibles, type of car, hierarchical relationships, some constraints about drivers and that sort of thing. How do we do this? We're going to do it with ontology languages. So basically building blocks. You're going to create ontologies with building blocks that are also consistent across ontologies. So you have the RDF and RDFS namespaces, which are just a way you define core concepts, classes, properties, literals, data types. And for our example car ontology, we can describe things like a car as a class. A convertible is also a class. It's a subclass of car, et cetera, et cetera. We can define properties. Driven by lets us define who drives this particular car, and it's under the domain of car. So if we're using driven by for a particular instance, we know that it's under the domain of car. So we can make we can learn things about the meaning and define things about the meaning. Then we can go on and also use more complex ontologies, which are built on top of RDF and RDFS to further, document our data space and describe equivalency of classes, inverse of relationships, narrower or broader relationships between classes. So using, for instance, OWL and SCOS. OWL stands for Web Ontology Language. They switched the O and W to get a cool acronym. And SCOS stands for Simple Knowledge Organization System, I believe. And that's really good for organizing hierarchical relationships, basically taxonomies, as well as applying labels to the classes that you define. All right. So how do we use these to create our car ontology? Okay, or actually we've created our car ontology now, right? And now we want to use it. So we can define a car instance here, my car, car1, as a convertible. Again, A stands for RDF type. It's just a shortcut there. And because we're using our ontology, we get a bunch of information for free, right? We have narrower, broader relationships, a hierarchy of concepts related to cars. We can apply these properties, say that my car is driven by a particular person, and then we can start to mix and match other well-known ontologies, right? As Charles mentioned. We can bring in FOF and say, well, this driver is a person. We can apply a name label to that driver. And odds are for your MarkLogic semantics applications, if you're leveraging ontologies, you're probably going to be leveraging a whole bunch of them. And that's really the power. Let's go through a few examples. So we talked about this sort of simple car ontology. What are the real ontologies out there that you'll probably be using with your MarkLogic semantic applications? There's Dublin Core, and that's use that for describing media, books, videos, movies. Dublin actually refers to Dublin, Ohio, which was a location of this Metadata conference back in 1995. And that's where they came up with the first core terms for Dublin Core. And here we're using Dublin Core, the properties to describe a book. And Dublin Core really is similar to FOF in a way, but for media rather than people and organizations, which is what FOF is used for. Geonames is a location ontology, and it's very powerful. Literally, it's millions and millions of triples. Everything we're talking about under the hood is triples. Standard triples for locations, for cities, for countries, for continents. And if you have a MarkLogic semantic application that includes location, you can integrate Geonames and get a whole bunch of stuff for free. Because every location in Geonames is also tagged with a latitude and longitude properties. And so that allows you to use geonames, not have to geotag the information yourself. Big time saver, don't reinvent the wheel. And here I'm just linking myself to where I am right now, San Francisco. And this is just a few example triples that are in geonames. Obviously, there are literally dozens and dozens of triples that describe San Francisco in geonames, and lots of probably every city in the world and every country in the world as well. And the last example I'll talk about is the World Bank topic taxonomy. This is a taxonomy. I talked about SCOS, how you create broader than, narrower than relationships. This is an example taxonomy, which means just a hierarchical ontology that uses SCOS under the hood. So you're defining relationships. You're also applying labels to these concepts. And here we've defined two concepts, power systems and smart grids. These are all economic concepts because that's what the World Bank deals with their documentation. And if you have a bunch of economic documents or what have you, you can also leverage the World Bank topic taxonomy, or maybe another similar taxonomy that is based on SCOS. So you can take everything I just talked about and put it in kind of this onion diagram. Now everything under the hood is triples and they're all linked together, but really there's a hierarchical relationship among all of them, right? There's RDF, which is property, type, these very core concepts that everything else is built on top of. You go to RDFS and OWL, SCOS, et cetera. And then on the outside you have these higher level ontologies that are more domain specific, Dublin Core, Geonames, World Bank topics, right? And if your MarkLogic semantic application then rides on top of these and utilizes these, your application is going to conceptually be the next layer of the onion here. So just to sum things up, ontologies, they help us model our data consistently, classify terms, characterize relationships, define constraints, and reuse design patterns. You're not reinventing the wheel, right? And you're leveraging a bunch of great information, in Geonames, all the geotagged, the latitude, longitude information. And really, when you bring that all together, it's enabling easier data integration. And I'll turn it back to Charles. He's going to talk about the multi-model nature of MarkLogic, as well as the powerful envelope pattern for integrating ontologies and other things into your apps.
Thanks, Mike. MarkLogic is multi-model. Everything we've said so far could really be any triple store. There are several triple stores out there, and you can go and use them, and all those triples, everything we've done so far is not old technology, it's still being developed. But MarkLogic really brings something else to the table, and that is that you don't only have to use triples. So let's think about what it means for data to just be sitting somewhere in a database. In a relational database, the data is not there unless you've already built a schema. You already know the meaning of the data before you put it in, or someone else built the meaning and you've hacked it a little bit to get your meaning in there somehow, and everyone knows what it really means, right? Well, in a XML or JSON database, which is based on documents, the document is the kind of atomic unit that we're going to put into the database, which is really different from schema, because I don't care what your document looks like. I can still put it in the database and get working with it right away. Triples are a little different from that, because in order to put things into a triple store, or let's say MarkLogic's the part of MarkLogic that is a triple store, you have to make triples. And so it can take quite a bit of effort, actually, to take your data and put it into triples first. But once you've done that, that's the substrate of everything that you're going to work with in a triple store. These are three really different ways of looking at data at rest. And the meaning in each of these cases, meaning means that the data that you've got is conforming to some kind of mental model of that data. Data by itself is not going to mean much. You can take a piece of data and interpret it as though it's part of a model, but it's really the model which contains the meaning of the stuff that's going over the wire. And even understanding data requires some kind of modeling on your part. The more formal that model is, the more you can share it with people, but we're doing it all the time. And data, as far as conforming to a model, it's kind of the same story as data at rest. If data is in a relational model, we're already done. We know that it's conforming to some kind of model already. That was its strength, and it's also its weakness, because you can't really change it once it's there. In a XML or JSON database, you can write schemas, XML schemas, which will tell you whether a particular document meets certain criteria, whether it's in or out. You can validate things. That's a very powerful way of looking at documents, and it's a way of making sure that your documents conform to a particular model. But it's not the only way of doing things. You can't mix documents, and it's very difficult to have mixed models with XML schema technologies. With triples, the meaning is all inherent in the data. It's just more triples. So I put a whole bunch of instance data in there, and then I can throw meaning triples in there. I put ontology triples in there, and it tells me how to interpret my data. The funny thing about it is I can put as many models in there at once as I want to. I can reuse the same data through multiple lenses, and it just depends on how I query it. At query time, that's when the model surfaces and makes sense. In a document database, the triples in MarkLogic, when we're talking about putting these triples, they're going into documents. We're still a document database. But it turns out that XML is such a rich and expressive data format that we can layer other data formats on top of it. So we just make triples in XML, and it doesn't really matter that they're triples anymore. What does that mean? The triples, you can go and find them. You can go and see the XML that is representing those triples. But once the MarkLogic has recognized it as such, they're put into a triple index, and that's the only place I'm ever going to have to look to get the values out. When you query for triples in MarkLogic, you're querying a triple index. Only when you go and get back source documents are you actually going to disk. So that's a good thing to keep in mind. So do you really care where these triples are? Well, maybe. There are really two ways of looking at triples in MarkLogic. You can think of MarkLogic just as another triple store. We implement all of the W3C standards for Sparkle protocol and Graph protocol, Sparkle update. These are managed triples if you're treating them like this. I can take RDF, put it in and just not worry about the substrate layer, the document layer. But there's good reasons why you might want to do what we call unmanaged triples. We call them unmanaged because MarkLogic isn't managing the triples, you are. You can also call them embedded if that makes more sense to you. You are controlling your documents and you're controlling where the triples are in the documents. Now why might I want to do that? I'll step back and think, MarkLogic is not just an operational database, it's also very good for data discovery. We often say you can load data as is, and you certainly can. But once it's in there, you don't have to stop. You can look at that data that you've loaded and then transform it, process it, and turn it into something else. And that's where you're going to actually think about what parts of your data you might want to embellish or put into triples. And this is, of course, this is the envelope pattern that you heard about this morning. This is a conceptual idea. We don't say use this envelope or that envelope. The whole idea of the envelope is that when you have your source data and wrap it up into something else, you can leave it as is. You can bring everything in and you don't have to touch it, so that if somebody needs to get that data out exactly as you put it in, it's not a problem. Just unwrap it again and you're done. This is a particular envelope where you can see that the raw data, the source document, just goes into one sub-element. And then there are other places in the envelope I'm going to stuff other things that I care about. I might do lexical transformations and put it in a metadata section. Well, triples are another section of your envelope if you want to. And you can see that there's this sem triples element in the semantics namespace, which contains children, sem triple children. If you make XML that looks like that, it's going to be triples. It's going to be indexed as triples, and you'll be able to query it with Sparkle or with the other libraries that support triples. Here's a kind of full view of an envelope, because this is 3 triples. You can see that they actually take up quite a bit of, they're pretty verbose. Of course, when we store things, it's all in a compressed tree. It's not as though we're putting all of this text in for triples all the time. But you can see that if you generate 100 triples from your XML data, it's going to take up quite a bit of room in your envelope. But conceptually, the idea is that you've got an envelope, you've got the sources, and then you've got extra stuff that you've done to it. How do you do this? With the transform function. If you're using the REST API to ingest or MLCP, you can invoke a transform function on ingest, or you can do it in place once things are already in there. So here's an xquery function that just takes the source. I'm going to construct triples somehow, either from that source or look up from other sources. I can go out with, MarkLogic has a HTTP client. I can go query things on the web. I can hit Sparkle endpoints on the web, bring things back in, and put them into my envelope and return it. Same thing with JavaScript, of course. You can make envelopes. You can make your envelopes with JSON if you want to. Really, you're going to choose XML or JSON envelopes depending on your source data. They don't mix well in the same node, so if you're dealing with XML sources or human-readable documents, make XML envelopes. If you're dealing with JSON data, make JSON envelopes. And just because it's xquery, xquery works very well with JSON too. I don't know if you have realized that, but the language you use doesn't have to do with the data model, really. And then once you've got these envelopes in place, you've got multi-model. You can do you can do CTS searches over your original data if you want to. If you've created a range index, or I can do range queries on elements. I can do, in this case, an element value query on the title. And I've got all of the MarkLogic features that you're already familiar with. On the other hand, since I've created triples and put them in the top, I can run Sparkle on it too. I can say select title, where book is title. But I'm really querying the same document in this case. It's just 2 different lenses on the same data. There's also CTS triples and CTS triple range query. Look those up if you are curious about composability in queries between triples and documents, because the triple range query is really a good integration point for that. This can be repeated more than once. If I have 7 different sources, I just have 7 different transforms. And the idea is that if I'm creating a consistent envelope, I don't care what's in that little source section. That's just coming along for the ride. If I'm creating a consistent canonical model in my envelope, then I have integrated sources into one single model simply by working with these transforms to get a consistent output out. So what kind of triples might you want to add? One thing you'll do all the time is you're going to have to create identifiers. Since identifiers and RDF are IRIs, you're going to have to hunt and peck for your corporate prefix, the left-hand side of your IRIs, and then find some combination of fields that actually create uniqueness in your source data and create IRIs. This is something you'll do over and over and over again for triples. One type of triple you might want to add is just typing. If I have a source document which is a product, I can just say, this thing is a product. And then from then on, I'll be able to query for all products in the database and get back all those documents which represent products. You might tag things with categories. This third triple actually tags the book with a Library of Congress subject heading. So I can integrate my books with subject headings that already exist simply by tagging them with the appropriate triple. I can link to document IRIs. I can say that not only do I have metadata about my book, what if I have the whole book in there as well? I can say, well, the content's over here, and if you want to go get that, just fn doc, you can get back the contents. And then lastly, you can just put basic attribute data in there. If I have a full-blown semantic system which is using Sparkle to get back attribute data about objects, those properties of the object can be right there in triples in your envelope as well. And then once you've done it, I can go and just search through all of my staging data and do a search for things within my source document and then decorate it. So this is an example of how you might construct a function to go and search for information and then create triples based on lookups and then stuff that lookup information into your envelope instead. So what can I do when I'm starting to combine these things? Or why would I want to make an envelope and put data, semantic data and document data in the same place? Here's one example. I can combine semantic lookups with search. If I have the triple Anna Karenina, his title is Anna Karenina, and the book goes on to say that all happy families are alike, I can write a Sparkle query and then include, as the fourth argument to that Sparkle query, I can include a CTS query. This is not a round trip. This is a one-shot operation. What this is going to do is run that CTS query as a restriction over, and then only the results of that query are actually going to be fodder for the Sparkle query itself. So I'm actually taking and partitioning my database beforehand before I decide to write a query. Here's another way of combining those two things. Let's say that Anna Karenina's subject is I think this is French Gothic literature. I didn't do the right subject, but you know about dirty data. So Napoleon entered an empty city. In this case, I'm going to search for Napoleon, and then I'm going to get back the subject heading for books. So I can find all of the subject headings that contain things about Napoleon in this way. I can access content with Sparkle. All of the built-in MarkLogic functions you can use in Sparkle queries. This is not a we don't need to, it's documented somewhere, but the implications are quite significant. Fn doc is a function that you can use in your Sparkle query. In this case, I'm actually returning the contents of the book because I've used lookup in my Sparkle query to go to disk and return the contents rather than just the title or something from triples themselves. So I can dereference IRIs right from within my Sparkle query. I can also join my derived triples with ones that are published on the web. So let's say I have a SCOS taxonomy of Library of Congress subject headings, which is a SCOS taxonomy, by the way. If I've got a subject tag for Anna Karenina, I can go and find the broader and narrower labels into which that book fits. So I can look at a particular book and then find out where in a hierarchy it sits, and that really enables semantic. Like this on the bottom right, there's a semantic facets which are based on a taxonomy. Each of those are tagged in my content. So I skipped ahead. Let me see here. Well, I'll do this first. So these IRIs usually exist in triples, but they can exist in your XML documents as well. And simply by virtue of putting this IRI in my document, that is a way I can join it to the triple data. So in this case, my triple range query is getting back everything that is a book, and then it's getting back all the values of the tags within there. And this is how you would use CTS to actually do fast facet counts on things that are leaf nodes in your SCOS taxonomy. Think about that. So why might you want to manage your own triples? In conclusion, they travel with their sources. Embedding triples in your document makes your document not just a tree structure, it also makes it an RDF structure. It's a multi-model in one place. And so these unmanaged triples also bring to fore some interesting MarkLogic capabilities involving semantics and search working together in the same place. So this is really your gateway to taking advantage of MarkLogic as both a document base and triples in the same spot. The last topic of this talk is going to be about inference, which is a little bit of a semantics-only way of doing things. But Mike will talk about how to actually discover new data based on the things that you've made assertions about in your triple store.
All right. Hello? OK. Inference. Powerful topic. So inference is all about determining new facts based on rules, OK? We all know semantics is about modeling facts out there in the world. So convertible as a car is one fact. Car as a motor vehicle is another fact. And we can model those as a couple of triples here. Now, any human being would see this and be able to make the logical jump that indeed convertible is also a motor vehicle. Well, we can allow MarkLogic to do the same thing with inference rules. So even though we don't explicitly say that a convertible is a motor vehicle, we can apply rules to our data and then materialize new triples based on those rules. So how is inference related to ontologies that I talked about a few moments ago? Well, it lets you leverage that extra information that you applied to your data set via the ontologies. So the subclass of information, the domain and range where you're linking together predicates with particular classes, inverse relationships between properties. MarkLogic can basically apply inference rules to make these relationships real in the form of new triples in your data. So let's just do a simple example here. Back to our cars, I have a user needs, show me all the red cars, all right? Our data mentions two cars, a red convertible and a red car. But we also have this subclass relationship based on, thanks to one of our ontology language widgets here, subclass of. So we can use an inference rule that basically says, what do we mean by subclass? And this is more generalized. I mean, it's not specific to our data, but it basically says, starting from the bottom, if we have a subject, that's a particular class. If that class is a subclass of another class, well, then moving up to the information in the construct block there, we can create a new triple. And when we apply that to our data at the top, we get a new triple saying our vehicle is actually a car, even though we've explicitly just described it as a convertible. All right, so a couple other examples just to solidify this. I mean, there are rules for the domain property from RDFS. Again, we can say if a car is defined as being parked somewhere, or I'm sorry, a vehicle is defined as being parked somewhere, well, then it's automatically under the class car. And that's the domain relationship. And there's a rule there that describes it formally. And via MarkLogic inference, we get a new triple out of that when inference is applied to our data.
Can I ask one question here? So
yeah.
These rules are being applied to specific constructs, so that's the scope of the rules, or does it go across any query?
I'll get to that in a moment. It's being applied to the data in your query, actually, based on how we're doing inference in MarkLogic, which will be the next step. Thanks. And one more example here is inverse of, which is from the OWL ontology library. So very simple, but if my vehicle is driven by me, well, then I'm also the driver of my vehicle. And so we're defining inverse relationship between two properties that we've defined in our ontology. We have an inference of rule here. And again, we're materializing new triples based on our data and based on the ontology information that's been applied. So simple example, but very, very powerful concept. So getting specifically to what we offer in MarkLogic, odds are you're not going to be able to be writing these rules on your own because MarkLogic ships with lots and lots of standard rules for semantics. All the properties in RDFS, and we have rule sets for RDFS, RDFS plus, which is RDFS and a few specific OWL rules, and OWL horse, which is all the RDFS plus, as well as a bunch of OWL-based rules. And here, the example code is rule sets can be imported into other rule sets. So when we're defining RDFS plus, we're just basically combining a bunch of rules that already exist in MarkLogic. Yeah. And all these rules are stored in the config directory under MarkLogic. So they're all there, written there in text files that you can, look at. So getting to your question, when are triples inferred? We can do it two different ways. There's conceptually you can do it theoretically two different ways. You can do it forward chaining, which is do inference during ingest. So each triple that gets ingested into a database, you could run a bunch of inference rules on it, right? And then add all those inferred triples as well and get everything in there on ingest. You can also do backward chaining, which is do it at query time. Just apply a set of rules that are relevant to that query and do it on the fly there. MarkLogic does backward chaining. Why do we do backward chaining? Well, we do backward chaining. Forward chaining, you're doing a whole bunch of work up front, which can be very costly if you're inferring lots and lots of triples that you're never going to really need in your queries, right? It slows down the ingest process, and maybe you're generating a lot of information that's not going to be used just to get complete coverage of what conceptually you might want to use, right? But also with MarkLogic in particular, it's very expensive whenever you do any sort of updates to your data. Because when your triple set of triples that are in your database changes, well, all the inference information that's there as well may have changed. Maybe no longer, a bunch of triples are no longer relevant. So you're going to have to be re-inferencing things often if you're changing that data. Whereas with backward chaining, you're working only on the partition of data that exists there for your query, right? So maybe you're querying on just a single collection. Well, you only have to infer triples based on the triples related to that collection. Or maybe the data in a directory, or those with specific security constraints. And again, you're only applying the rule sets you need at query time.
So the recommendation is not to do it during the ingestion process?
Well, MarkLogic doesn't do it during the ingest process. If you want to do it during the index process, knowing stopping you from writing that code yourself during your ingest. But the MarkLogic inference happens at query time. So inference performance, the more you can restrict your Sparkle queries based on, say, type or a property or what have you, the more restrictive you're feeding into MarkLogic, the better performance you're going to get, right? If you have unrestricted Sparkle queries, that's just a recipe for slower inference performance. And the more you can constrain the rules you're applying, the better performance you're going to get. Because inference is also a recursive, phenomenon. If you get new triples based on a subclass relationship, well, they may generate those triples, inferred triples themselves, may generate more based on transitive rules and so on, and it builds out from there. And also, inference at query time, you're storing these new triples in memory. And it's a fixed memory size, which you may want to adjust depending on how inference heavy your semantic queries are. And you can do this under the admin UI. So that's it for inference. I'm going to hand it back to Charles briefly. He's going to wrap a nice bow around what we just talked about,
Well,
all the different things.
A nice bow. We've come to the end of our time. Essentially wanted to just shower you with some concepts about MarkLogic and semantics at the same time, and to think about how semantics provides this big toolbox for easily moving data around, for easy data modeling. It's a very powerful way to do multi-modeling because you can put as many models in your database as you want to. And then there's this whole range of standard vocabularies that you can draw on for your applications. MarkLogic adds to that by putting documents and triples together and allowing you to choose what kind of document, what kind of modeling you want to do, or a combination of them. You can also link your documents to triples in MarkLogic and query them together. And then lastly, you can actually integrate the search capabilities with semantic capabilities by using built-ins inside your Sparkle queries or by feeding the results of Sparkle queries to semantics. So if we do have any more time, here's our information. You can get a hold of me or Mike. Twitter's a good way to do that. Or you can come up and talk to us tomorrow during the expert sessions. And now, if we have any time left, there might be time for 1 or 2 questions.
So the envelope is meant for combining the triples in the document?
The envelope pattern itself doesn't have to have triples in it. It's just one thing you could put in the envelope besides your original documents. The purpose of the envelope is just to say, I can keep what I have now and add more things to it. I didn't go into other uses of the envelope, but there are other reasons to add other kinds of metadata besides just triples.
So when I query using the REST API call, the inference REST API call, will I get the triples also back in the document, or is that I have to go through and put the canonical model which David was talking about?
If you do nothing at all, you'll get back the whole envelope with everything wrapped in it, including the triples. They will look like XML or JSON. They won't look like triples. But you'll get back the whole thing. The idea is if you want just the source document back, it's a very straightforward transform to strip that, unwrap it back, and give you back the original document. Right.
So you mentioned when triples are inside the document, they are called unmanaged triples. And I'm trying to understand, what do you mean by unmanaged? What am I losing when I just manage triples outside as a normal triple store?
Well, that's from the perspective of the database itself and how the documents are arranged. So if we say manage triples, we are deciding where and what documents the triples go. And if you're dealing only with triples over the wire, then MarkLogic's deciding to put them into documents based on its own criteria. Unmanaged means that you are in control of them yourself, and you are deciding which documents the triples go into. That has implications for Sparkle Update. Sparkle Update is a language, a W3C language for doing updates on triples. It does not work on triples that you are managing. It does not work on unmanaged triples. This is something to keep in mind. Yes. Right. Yes.
Is it true that the only way to leverage CTS search along with semantic search is by putting them together within the envelope?
It's not the only way. What you gain, the CTS library really depends on things being in the same document together in order for them to be aware of each other. So the reason for the envelope is that you have your document data and your sources and whatever metadata you've chosen to add all together in the same place. So if I do a search and return it, I'm going to return results based on all of the data in the envelope. Does that answer your question? Okay. Unmanaged triples, in other words, managed triples, where we are controlling where the documents are. If you do search on those, you'll get back a document, but you won't know why it has the triples in it that it does. You could think of it that way.
Is there an advantage to using the envelope pattern over using the documents or the properties fragment?
Absolutely, there is. The properties fragment is a very useful thing, but it actually takes a join to join things from the properties fragment to the document fragment. And it turns out that there's a lot of benefit to having things in the same fragment. That's what the envelope pattern gives you.
In the first slide, you said semantics with the big S, the graph is like a set of RDFs.
Yes.
Did you show us that later?
I don't know that I did. I may have had to, we cut like half of this presentation just to get it into here. Well, you saw this morning in the keynote where you had bubbles associated with lines between them. If you take a bunch of triples and say that two things are the same, it becomes a chain. And a graph, you can name graphs. If you have 100 triples, they don't have to be connected, but just a set of 100 triples, you can name it and insert that as a named graph. So it's just a way of collecting a bunch of triples together, and I'm saying I'm managing them together. And you're always going to want to do that, or you're often going to want to do that because triples usually travel together. It's very rare that you're going to want to do something with just one triple. They are usually going to be an entity represented by a couple dozen triples or something. If they're all named the same thing, I can replace them all at once without having to worry about the internal shape of the entity.
I'm sorry, yeah, that's, we have to let the class out for the new session, so that's all the questions we can take at the
All right,
moment.
thanks,
Thank you, I
everybody.
appreciate it though.